Hello class, welcome to Unit 9, Video 2. Today we're going to look at adding and subtracting rational expressions. Your learning target for today is that you can add and subtract rational expressions. Yesterday we looked at multiplying rational expressions. Remember when you multiply, if you have two fractions, like let's say 3 over 2 times 4 over 7, okay, you multiply across. Okay, so if in this case, if you look, can I cancel anything? Well, they're both divisible by 2. So then I would have 3 times 2, which is 6 over 7. Okay, if I had the same type of problem and I was adding or subtracting, you can't just add across. Okay, if I have 2 over 3 plus 1 over 2. In order to be able to add or subtract, remember, you need to go ahead and get that common denominator. So in between 3 and 2, my common denominator would be 6. So I'd multiply the top and the bottom by 2 on this one, and this one by 3 to get them to the denominators to be 6. So this would give me 4 over 6 plus 3 over 6. And now that my denominators are the same, I can add my numerator. So I would have 7 over 6. Okay, so just some things to remember when we add or subtract versus multiplying and dividing. All right, so we have an example. In order to produce a picture that is in focus, the distance between the camera lens and the film cue must be controlled so that it satisfies a particular relationship. If the distance from the subject to the lens is p, and the focal length of the lens is f, then the following formula, 1 over q equals 1 over f minus 1 over p, can be used to determine the correct distance between the lens and the film. So here's our example. We have, if f is 5 over 6, 1 over p is equal to 1/4, and we want to find 1 over q. So let's plug this in. We're finding 1 over q, so I have 1 over q is equal to 1 over f, which is 5 over 6, minus 1 over p, which is 1/4. Okay, so in order to subtract, we got to get that common denominator. So I think 6 and 4, what is my common denominator? What can I get them both to be? That would be 12. Okay, so I would multiply this times 2, and to get 4 times to 12, we'd have to multiply by 3. So 2 times 5 is 10 over 12 minus 3 over 12. Remember, when you add or subtract, denominator stays the same, and then 10 minus 3 gives me 7 over 12. So 1 over q is equal to 7 over 12. Okay, so that's how you add and subtract with our fractions. Okay, when you're finding your common denominator, what you're really doing is finding your least common multiple between these two. Okay, so if I was just talking about 6 and 4, what you can do is you can do the factor tree. 6 breaks down into 2 times 3, and 4 breaks down into 2 times 2. The way you could find your least common multiple, the smallest number that they both multiply to, is you take the greatest number of numbers. So it sounds funny, but if you look, 6 has 1 2 and 4 has 2 2s. So you write down the biggest number, which would be 2 2s. So the LCM would be 2 times 2. This has no 3s, and this has 1 3, so I would write down 1 3. 2 times 3 is 4, 4 times 3 is 12. Which is what we use for our least common multiple, and that was our denominator. So we're going to be finding the least common multiple of polynomials. Okay, the way you do that is the least common multiple of polynomials in factored form contains each factor the greatest number of times the factor appears. Okay, the greatest number. So here there was 2, so I wrote it down twice. Okay, so it was the greatest number of factors. So LCM of 6 and 4 we actually just did. So LCM of p minus 1 and p squared plus 6p minus 27. Okay, so we would have p minus 3. This one factors down into what multiplies to negative 27 but adds to 6. 9 times 3 gives you 27. If I want a positive 6, I'd have positive 9 minus 3. Okay, looking at my factors to figure out my LCM. Okay, this is p minus 3, and there's 1 p minus 3. So the greatest number of factors, it's listed once and once. So I'd write it down once. P plus 9 is written once, it's written 0, so the greatest number of times is once. So p plus 9. So my least common multiple would be p minus 3, p plus 9. Okay, so steps to finding the LCM. We want to factor all polynomials, and then multiply each polynomial by the factors if it is missing, and then use each factor the greatest number of times it appears as a factor. Okay, so we're just going to look at some examples. I think that will make things make a little bit more sense. Okay, so we're going to find the LCM of the following monomials. Biggest thing is they're monomials, they're singles. So we do not need to factor, okay, when they are monomials. All we need to do is we need to do the factor tree. Okay, what does 12 factor into? It's 2 times 6, and then it's 2 times 3. Okay, so 12 is really 2 times 2 times 3. 27 is 3 times 9, and 9 is 3 times 3. 18 is 2 times 9, and then 3 times 3. So I would look at this, and to figure out my LCM of those three monomials, I would say there is 2 2's listed here, no 2's listed here, and 1 2. So you write down the biggest number of 2's, which was 2 of them. Then here there's 1 3, here there's 3 3's, and there's 2 3's. So you write down the biggest number of 3's. There was 3 3's in 27. Okay, that takes care of the number. Now we look at the variables. This one's actually easy. We are going to just go ahead and take the biggest exponent. So we have a squared, a to the first, and a to the fifth. So it's a to the fifth. B to the fourth, no b, b squared. So b to the fourth. And lastly, c, no c, c to the third, c to the first. So c to the third. So then all we need to do is say, well, what is 2 times 2 times 3 times 3 times 3? Well, you can put that in your calculator if you need to. It is 108. A to the fifth, B to the fourth, C to the third. There is my answer for example 2. Okay. Number 3. Go ahead, I would do the same thing. Let's break down 6. 6 breaks down into, once again, 2 times 3. 42. It breaks down into 2 times 21. And this breaks down into 3 times 7. 36 is 2 times, not 36, times 18. 2 times 9, and that breaks into 3 and 3. So my LCM for this one, there's 1 2, 1 2, 1 2 2's. So I'm going to write down 2 2's, 2 2's. All right, 3. There's 1 3 here, 1 3 here, 2 3's here, so write down 2 3's. No 7's, 1 7, no 7, so 7. Okay, so that's going to take care of our number. So let's just write what that is. So we have 2 times 2 times 3 times 3 times 7, 252. Then I look, m to the third, m to the first, m to the third. So the biggest one is m to the third. N's, n to the fifth, n to the first, n to the fourth. So n to the fifth is the biggest. No p, p squared, p. So p squared is the biggest one. So there's our least common multiple for example 3. Okay, so this is with monomials. Now we're going to go ahead and look at trinomials. So what we need to do with these is you need to factor. Okay, so here's my new little fact with that one. Gotta factor. So let's factor it. The first thing you always want to look for is a GCF. Looking at this first one, they all have a p, so I'm going to factor out a p. Okay, then I'm going to factor a little further. I have p. And then what multiplies to 6 but adds to 5? They're both positive, 2 times 3. Okay, now I'm going to factor this polynomial. What multiplies to 9 but adds to 6? 3 times 3. Now I look to find my LCM. There's 1 p here, no p's here, so a bigger number is just to write down 1. 1 p plus 2 here, no p plus 2, so I write down 1. 1 p plus 3, 2 p plus 3, so I write down 2. So there's my LCM. Another way it could be written, just so you can tell if I write it like this on the answer key, squared, right? Because there's 2 of them. So there's my LCM for example 4. Example 5, let's look at that one. All right, we have another, let's see, This is not the one on your note sheets. Here it is, number 7. Sorry about that. This is actually your number 5. All right, number 5. Let's look at this one. Okay, look for GCF. Okay, well, they're not all divisible by 2, so I can't take out a 2, but they all have a k. So I'm going to take out a k. So I'd have 2k squared minus 5k minus 12. Now I would factor. Now this one's different. Notice how there's that 2 in front. So the first number has to multiply to 2k squared. The only thing that multiplies to 2 is 2 times 1. Okay, so there, that checks out. Then I'm going to go ahead and try 12. What multiplies to 12? Let's try 4 and 3. Then the way we get 5 is we check. This gives me 4k when I multiply, and this gives me 6k when I multiply. With these two numbers, can I get negative 5k? No, I cannot. So that doesn't work. Flip it around. Try 3 here and 4 here. This gives you 3k. This gives you 8k when you multiply. With those two, can I get negative 5k? Yes, if this is negative. So that means when I multiply, this is negative and this is positive. So there it is factored. So that's when you have to do guess and check. When that a in the front is not 1, you're going to have one of those on your test. So make sure you're ready for it. All right, looking at this next one. Okay, I'm going to factor out a k of here. So I would have k squared minus 8k plus 16. So now this one's back to our original way of thinking. What multiplies to 16 but adds to negative 8? Negative 4, negative 4. There it is. Now, LCM. This one has a k and this one has a k, so I write down 1k. 2k plus 3. There's 1 here, none here, so I write down 1. There's 1k minus 4 here, and there's 2 over here, so I write down 2. All right, and then just so you know, once again, since there's 2 of them, I can write it as k minus 4 squared. Whoops. Squared. And that would be my LCM. Okay, so the LCMs, we use those to find the common denominator. Okay, so when we're trying to find a common denominator for our rational expressions, this is the process you may need to do in order to figure it out. Okay, so adding and subtracting rational expressions. Just like factors, to add or subtract rational expressions, you must have common denominators. Biggest thing is getting those common denominators. Okay, so I have 2 little examples here just so we can remember how to do these as well. If I look at this one, I have 3 and 5. What is their least common multiple? Well, 3 breaks down into 1 times 3. 5 breaks down into 1 times 5. So my least common multiple would be 1 times 3 times 5, which is 15. So I would have to take this times 5 and this times 3. So that gives me 10 over 15 plus 9 over 15, which gives us, add the tops, 19 over 15. That's my answer for that one. Doing this other example, this one's a little bit trickier because it's all variables. Maybe it's tricky, maybe it's not. So I would have to have a common denominator. Well, I know I have to have a d over here, and here I'd have to add a c. So I would have AD over CD plus BC over CD. And I would say, well, they both have a common denominator, so my numerator is AD plus BC over CD. So this is the type of expressions we're going to be handling today. Okay. So let's just go ahead and get started on some of these examples. All right, number 6. This should say number 6. All right, we have monomials everywhere. So what we're going to do is we're going to say, well, what should the LCM be? The LCM would be, well, what does 15 break down into? 3 times 5, and 18 is 2 times 9, which is 3 times 3, right? Okay, so my LCM, there's 1, 2, There's 1, 3 here. There's 2, 3, so I'd write down 3 of them. And there's 1, 5. There is an x and y squared. So 2 times 3 times 3 times 5 gives us 90xy squared. So this is what our common denominator should be. Okay, so I'm just going to erase what I have right here so I have enough room. All right, so I need to get 15 to 90. Well, 15 times what gives you 90? 15 times 6. So I multiply by 6 on the top and the bottom. And then I need to have xy squared, so times x. 18 times what gives you 90? 5. Then I need to have xy squared. I have xy, but I need y squared, so I need to multiply by y. So my numerator, I have 6 times 7, which is 42. And then I have x times x, x squared, over 6 times 15 is 90xy squared, plus 5y times y will give me 5y squared, over 5 times 18 is 90, and then I have my y, so xy squared. Now I have a common denominator, so it's really 42x squared plus 5y squared over my common denominator. Just write the common denominator once. I cannot combine these in any way, shape, or form. They're not like the same term. So this is my final answer. Okay, don't try and cancel things after you've done it. You would just undo getting your common denominator. So that's my answer for number 6. All right, number 7. Let's look at this one. So LCM. Maybe you like to find it. Maybe you can see it right away. You don't have to write the LCM out if you don't want to. LCM. 9 breaks down into 3 times 3, and 7 is 1 times 7. So my LCM would be 1 times 3 times 3 times 7. Okay, then I would have a b to the second. So my common denominator would be 63 a b to the second. So that's what I want to get for my common denominator. Maybe make a little note. Okay, so from here, I know I want to take my 9 times 7, and I want ab squared, so times ab, 7ab, 7ab. This one I would have to take times 9, and I want ab squared, which I already have, so just times 9. So what's that going to give us when we do that? Well, I'd have 7 times 8, which is 56. A times a is a squared, b, all over 7 times 9 is 63 a b squared, minus 1 times 9, so 9 over 63 a b squared. I have my common denominator, so I can add my numerators together. All over 63ab squared. Can't simplify any further, so that is my final answer for example 7. Okay, example 8. Okay, so this is number 8. Least common multiple for this one. This is really 1, so really I just know I need to get it to 8. M squared, n squared. So that's my goal. That one's pretty easy to see what you need to add. So if I need to have n squared on the first one, I need to take it times n on the top and the bottom. Over here, I need to have 8m squared n squared. So I would have to multiply by 8m. So I would have n over 8m squared n squared plus 2 times 8 is 16m over 8m squared n squared. My denominator is the same, so I can go ahead and write it as 1. So I would have n plus 16m over 8m squared n squared. And that is my answer for number 8. Okay, number 9. Now would be a good time to pause the video and try and do number 9 on your own. Okay. 3 and 5, both prime numbers, so I know my LCM for those two would be 3 times 5, so 15, and then I would have to have xy. So it's my least common denominator. So I would have to get this to 15, so I'm going to multiply by 5. And I already have the xy, so this one I need to just multiply by 3x. So 2 times 5 is 10 over 15xy minus 9, and then x times x, so x squared over 15xy. I have a common denominator, so I can write my numerators together. Once again, they are not like terms, so I cannot put them together. And that is my answer for example 9. Okay. Numbers 10, 11, 12, and 13. We're going to switch gears a little bit. Okay, these were all monomials. Now we're going to get to trinomials. Okay, so when we have trinomials or things that can be factored, we need to factor. Okay, so binomials, trinomials, look at GCFs, things like that. Okay, so number 10. I would look at this one and I would factor your denominators. I can take a 4 out of here, so I would have w minus 4. And out of here I can take a 2. So let's think about my least common multiple. This breaks down into 2 times 2. So my least common multiple, or my common denominator, will be, there's 2 2's and 1 2 here, so it's 2 times 2, and then they each have a w minus 4. So my goal is to make it 4w minus 4. Currently, I have 4w minus 4 on my first fraction, and this one's 2w minus 4. So how do I make this be 4? I would times it by 2. So you do it to the top and the bottom. Okay, so now I would have w plus 12 over 4. I'm just going to write it as 4w minus 16 minus 2 times w plus 4 all over 2 times 2 is 4, so I would have 4w minus 16. My denominators are the same, so now I'm going to combine like terms in the numerator. Here's where you need to be careful. This is a negative, so it's really a negative 2, so I'm going to distribute a negative 2. So I have w plus 12 minus 2w minus 8 all over 4w minus 16. Now I'm going to combine like terms. W minus 2w is negative w. 12 minus 8 is 4, so plus 4. All over 4, and this is w minus 16. So I would look back and I'd see, well, maybe they could cancel something. Okay, here's where you have to do a little more work, is in when there's factoring. Okay, so taking this, currently I have negative w plus 4 over 4 parentheses w minus 4. Okay, if I factor a negative out of my numerator, is anything the same on the top and the bottom? Yes, I would have negative w minus 4 all over 4 w minus 4. So I can cancel these. When I cancel, there's really a negative 1 sitting in front of here. So my answer for this one is simplifies all the way down to negative 1/4. Okay, so once you do the adding and subtracting, this comes back to our multiplying yesterday, how you have to cancel and simplify. So just make sure you're checking and make sure you're not missing something that could cancel. Okay. Number 11. All right, let's factor those denominators. This is really x plus 2, x minus 2. This is x plus 2. So I can already see, okay, what my common denominator would probably be. This one's already has an x plus 2, so I just really need to add an x minus 2 to this one. Then I can look, they're the same. So I have 1 over x plus 2, x minus 2, then plus, I'm going to distribute this x. X squared minus 2x all over x plus 2, x minus 2. Now I can write it as 1. I'm going to write it in order. So x squared minus 2x plus 1. And then I would have x plus 2, x minus 2. Then I would just check, does my numerator factor? Is there anything that multiplies to 1 but adds to negative 2? Well, negative 1 and negative 1. Okay, so then I would look, does that mean that anything cancels here? Are any of these the same? No, so I can just leave it. You can leave your final answer as x squared minus 2x plus 1, and I'm going to write this as x squared minus 4. You could use either denominator, but I like to write the one that has less work to write, so there you go. That is number 11. Number 12. Okay, first thing I have to do, factor the denominator. You look at this when you're a little disappointed. It's going to be a little more work because my a is not 1. So I know I'm going to have a 3 in the front because these two need to multiply to the first term, which is 3x squared. Then I would try 5. Okay, let's just try. The only thing that's a multiply to 5 are 5 and 1. Then remember we check it. So this gives me 5x. This gives me 3x. With those two, can I get to 8x? Yeah, if they're both positive. So I got it right away on my first try. So that's good. All right, so this part is really what we have written here. This factors too. Let's see, I can take out 4. So I would have 3x plus 5. Okay, so that looks good. So you could maybe look at this one and see. Okay, this has a 3x plus 5. This has a 3x plus 5. This has an x plus 1. This is missing an x plus 1, so I need to add an x plus 1. Okay, do they look exactly the same? Not quite. This one has a 4, so I need to add a 4 onto this one. So just remember, if you add a 4, you really gotta factor and distribute that. So let's simplify. Okay, this is going to give me 4x minus 4 over my 4, 3x plus 5, x plus 1, minus, now I FOIL this piece. Okay, if you FOIL this, you're going to get x squared plus x minus 1. So we're left with x squared minus 1 all over our common denominator. Let's go ahead and write it as 1. Just be careful because this is a negative. So we need to distribute a negative. Okay, so it's really going to be, I'm going to write up top, negative x squared plus 1. So I'd have negative x squared, then 4x, and then I combine negative 4x and 1, so minus 3. All over 4, 3x plus 5, x plus 1. Okay. The last thing you need to do is check, does my numerator factor any further? So I would take out a negative to try it. (3x plus 5). Okay, so what multiplies to 3 but adds to negative 4? So we would have x minus 3, x minus 1. And I would look, does anything cancel? No, nothing cancels. So I can just leave my answer all foiled. There it is. So that would be my answer for example 12. All right, we have one last example. I would recommend that you pause the video and maybe try this one on your own. This is example 13. Okay, when it's a trinomial, we got to go ahead and try and factor it. So it multiplies to 20 but adds to negative 1. Negative 5 and positive 4. Okay, so that's what this is. Now I would just say, this is a minus 5, a plus 4. Here's a plus 4, so we need to add an a minus 5 to the top and the bottom. So I really have a over a minus 5, a plus 4, plus, I'm going to distribute this to 2a minus 10 over our common denominator. Now from here, I can add my numerators together so I can combine these. So that's going to give me 3a minus 10 over a minus 5, a plus 4. There's nothing that factors out of here, so I am actually all done. The one thing I would say is you can write it like this, or you can leave it as what we had originally before we factored it. A² minus a minus 20. Either one is perfectly fine. So that is it for Unit 9, Video 2. If you have any questions, please let me know. This is a lot to take in, so please let me know if there's anything you're confused about. Otherwise, have a great day, and I'll see you later.